In a previous video, I explained how to use integration to find the areas enclosed by algebraic graphs and the reference axis. In this video, I'm going to do a more advanced question where we are finding the areas enclosed by two graphs and the reference axis. Now, this is the question that we have. Question number 5.1.1 says sketch the graphs of x squared plus 4y squared equals to 16 and x squared plus y squared equals to 16, and you show the area bounded by the graphs in the first quadrant and show a representative strip perpendicular to the x-axis. If you listen to this question, it is actually giving you guidance on how you find the area bounded by graphs and the reference axis. I have explained in a previous video how the processes that you should follow, and this question is actually a leading question because it is telling you that the first thing you need to do is to sketch the graph and you show the area that they're talking of in the first quadrant and show a representative strip that is perpendicular to the x-axis. So you don't have a choice here. They want a strip that is actually vertical. That is what they want. And after that, you can now calculate the area that they described in question 5.1.1. In other words, let me just do a recap of the steps that you should follow. These are the steps that you should follow. Here they are. First, you sketch the function accurately. If there are two graphs, whatever number of graphs, you sketch them. Then you identify the required area. Then you choose a differential element, which is this strip that we're talking about. And then after that, you deduce a function in one variable and do the integration. If we go back to our question here, if we go back to this question, it is giving you all these steps here. It's actually giving you a hint of that you should follow these steps. Now, because sketching graphs is part of this application of integration, whether it is volumes or areas, you need to master the art of sketching graphs. So if I look at my graphs here, I see that this first graph here is an ellipse. So this is an ellipse. The other graph here is a circle. So this is an ellipse and the other one is a circle that is centered at the origin with a radius of 4. Armed with that knowledge, I can quickly and easily do my sketch. So let me go to the sketching. I'm going to sketch these graphs. So I said, if I look at the first, this one, the first graph, I'm just going to rearrange it in a certain form. I'm going to divide by 16 throughout. I'm going to divide by 16 throughout here. If I do that, I will get x squared over 16. That's x squared over 16 plus, if I divide 4y squared by 16, I get y squared over 4 equals to 1. I can rearrange this to be in the form x squared over 4 squared plus y squared over 2 squared equals to 1. So this is an ellipse. This is an ellipse with a major diagonal having a length of 8. In other words, it's 4 to 4. So this is an ellipse. Center is the origin. It's centered at the origin. It has a major diagonal. Major, not major diagonal. Yes, it is a major axis. It's called a major axis, which is 8 centimeters long. It's from minus 4 to 4. This is the major axis of this ellipse. It's from minus 4 to 4. Then the minor axis is from minus 2 to 2. So this is on the x-axis. This is on the x-axis. This is on the x-axis. So the major axis is actually on the x-axis. The minor axis of this ellipse, minor, is from minus 2 to 2. And it is on the y-axis. I am getting all this information from this standard form. This is the standard form of an ellipse. This is the standard form of an ellipse. If you know the standard form of an ellipse, you can easily sketch an ellipse. So if you don't know how to sketch an ellipse, you should learn how to sketch an ellipse, because you're going to need that knowledge in solving these kind of questions. Then, so this is for the ellipse. I come here to our circle. This is our circle. How do I know it's a circle? Because I can write it in the form x squared plus y squared equals to 4 squared. And we know that the general form of a circle, the general equation of a circle is x squared plus y squared equals to r squared. So this is actually the radius of our circle. This is the radius. And our circle has center, that is the origin. The center of the circle is the origin. With all this information that I can get so quick, I can be able to do my sketch. So let us move from here to do the sketch. I'm going to sketch the two graphs on the same Cartesian plane. So let us come here and do the sketch. So this is going to be our sketch. Sketch here. I'm going to start by sketching my axis. So I have a vertical axis, the y-axis is here, and a horizontal axis. This is my x-axis, and there we are. Now I'm going to do a sketch of the circle. So this is my sketch of the circle. I'm going to take the sketch of the circle. Let me sketch the circle. So this is my circle. No. I'm going to sketch my circle here. All right, let me just. All right. So we sketch the circle. What do we know about this circle? We know that it's going to come to 4 here. There's a 4 and minus 4, because this is the radius of the circle, by the way. A positive 4 here and a minus 4 here. This is my circle, so I'm going to draw my circle. This is the sketch, by the way. This is the sketch, guys. This is the sketch. All right, that is the sketch of my circle, and it is done. Just make sure you are showing all the important areas, all the important points on the circle. Then the other shape that we have is an ellipse. So we have an ellipse. I'm going to draw my ellipse. All right, let's draw an ellipse. Actually, the ellipse will be like this. So our ellipse is on the major axis. It is coming. Let me use a different pen. On the major axis, it's coming to 4, positive 4 for x and negative 4. But on the minor axis, it's coming here in the middle, where we have a 2 and a minus 2. So this can be the sketch of my ellipse. Come here, go down, come here. Please, guys, forgive my sketch, but then this is a sketch. We come here. Now, the inner one is our ellipse. So this is our ellipse. And the outer, this one is our circle. So we have a circle and an ellipse. The area that we're worried about, it is the area in the first quadrant. So this is the first quadrant. So we have a first quadrant here, second quadrant, third quadrant, and the fourth quadrant. We don't care about what is in the third quadrant and the second quadrant. We're just worried about what is in the first quadrant. In fact, let us go back to our question and read it properly. This area is bounded by the two graphs. Yes, it is bounded by the two graphs in the first quadrant. That's what we're worried about. So we just have to go there and do the drawing. So this is the area. I'm just going to highlight it in a different color. Let me use blue. So this is the area here we're talking about. This is the area. We're showing the area. That's okay. The question also wants you, in question number 5.1.1, it wants you to show a representative strip. So show this representative strip. So we go back to our graph and we show a representative strip. I'm going to use a different color for that. So this is our representative strip. It's a vertical strip because it is perpendicular to the x-axis. So this is our representative strip. Perfect. We are done. Maybe I can just shade it a bit, but this is our representative strip. If we look at the representative strip, this one, it is a differential element dA the breadth or the width of this strip is dx. Since it's a vertical strip, it is dx, and the height of this strip is actually y2 minus y1. If I call the circle here, let me call my circle y2, and I call this one y1. The height of this is actually y2 minus y1. y2 minus y1, such that if I'm looking for this area here, it will be this area. I will have to integrate. I'll have to integrate dA from x equals to 0 to x equals to 4. I do the same here. I'm integrating from x equals to 0, x equals to 4. Okay, I said dA, it will be this times dx. Obviously, that is our differential element. And from here, from this, I can find the area that I'm looking for. Very, very important. Very, very key. But question 5.1.1 is done already. I'm done with question 5.1.1. I have sketched the two graphs. I have indicated the area that is bounded by the two graphs in the first quadrant. I have also shown the representative strip that is vertical or that is perpendicular to the x-axis. I have done that, which means I have answered all this part here. I should get my marks for this part. I have done everything. I'll get the three marks. Now, question number 2 wants you to calculate the area. Now, I'm going to go now to the process of calculating this area here. Now, to calculate the area, I'm going to rely on what I have here. I'm going to rely on this formula. Remember, this is the formula that I deduced just now. So, area will be integration from 0 to 4. 0 to 4 are my limits of integration. Always look for consistency, guys. Always look for consistency. What I mean here is if you're integrating with respect to x, your limits of integration should be x values, and these functions here should be expressed in terms of x. Very, very important. I said my y2 is the circle. So let us write the equation of the circle. We know the equation of the circle is x squared plus y squared equals to 16. This is the equation of the circle. So from here, I can make y subject of the formula so that I have a function or an expression in terms of x that I'll substitute here. This means y is equals to the root of 16 minus x squared. So this is my y2, by the way. This is my y2. So I'm going to substitute y2 here as an x expression. I'm doing that because I cannot integrate with respect to x when I don't have an expression that is in terms of x. Now I go to my ellipse. The equation of the ellipse is x squared plus 4y squared equals to 16. Okay, let me check to confirm. Yes, x squared plus 4y squared equals to 16. That is my equation of the ellipse. Now I have to make y subject of the formula from this so that I can have y1. So let me close here and come back here. Now I want to make y subject of the formula from here. If I do that, I will have y is equals to, which will be y1 by the way, it will be equals to half the root of 16 minus y squared. This is my y1, such that I'm going to put this one here. Back here for y1, I'll replace it with a function that is in terms of x. So I'm going to put this back in here. This is what I'm going to do next. That is my following step. Now let us go to do that. I'm coming here. Fine, I'm looking for this area. I'm just going to come here and do the integration. So in reality, this means I'm integrating the area that we're looking for. The area A is equal to the integration of my y2 is the circle equation, which is the root of x squared this is the root of 16 minus x squared minus half the root of 16 minus x squared, all of this dx, and we're integrating from 0 to 4. Very, very important that you do this. If we look at what we have here, we can actually subtract the two. We can subtract this one minus this one, and we get half. So if we do that, we get half root of 16 minus x squared, which we'll write like this. I can take out the half. I'll write it like this. Half integration from 0 to 4 of the root of 16 minus x squared dx. Now I want to use a certain formula that I can use from the formula sheet, but this formula, I can use it if I modify my integral. I'll modify my integral to be half integration from 0 to 4 of the root of 4 squared minus x squared dx. I have a formula on the formula sheet that says, I have a formula on the formula sheet for the integration of, let me write it in a different pen. I have this formula here that says integration of root of a squared minus b squared x squared dx. I have this formula here on my formula sheet. This is the formula that I'm going to rely on, such that from here, from this, I know that my a is equals to 4, my b is equals to 1, and my x is equals to x. So I just look for a formula in this manner, and then I apply that formula to get this integral. This is how you evaluate this integral. So I'm going to continue on a new page. I'm going to continue on a new page. So let us add a new page here. All right. Now, let's move from here and come here. So now we are integrating. We know that our area is the integral from 0 to 4. There's half here of root of 4 squared minus x squared dx. If I apply this formula, this means half So we're going to apply the applicable formula, and this is the applicable formula. This is the applicable formula. This is the applicable formula. We find this on our formula sheet. You should have this formula given to you. Now we're going to apply that, knowing that our A is 4, our B is 1, and our X is X. Let us do that. So this means half. This means half at a squared, which is 4 squared, which is 16 by the way, so it's 16 over 2b, which is over 2 times 1, so it's over 2. Arcsine bx, x is 1, so this is just x, over a, which is 4, plus x over 2, x over 2, root of a squared b minus b squared. So a squared is actually 16, because it's 4 squared, minus b squared, which is 1, x squared. This is it. And then we put our limits of integration. I'm just going to wrap out this part here. It has done its job. So this is from 0 to 4. Once we are here, all we need to do is to substitute our upper limit, then subtract the lower limit, and do a bit of simplification. So this actually means 1 over 2. I'm going to substitute 4 into this whole expression here. So this is 16 over 2, which is actually 8. So we have 8 here. Arcsine of 4 over 4, where there's x, I'm putting 4, plus x over 2, which is 4 over 2, root of 16 minus 4 squared. We close this. Minus. Now we check if we put 0 into this whole thing here. If we put 0 into this whole formula, what do we get? Now it is 8 arcsine of x over 4, which is 0 over 4. So this is 0 over 4, plus x over 2, which is 0 over 2, root of 16 minus 0 squared. We close this. From here, all we have to do is just to punch in our calculator and get an answer. That's all. You just have to punch in your calculator and get an answer. If you look at the second bracket, really, if you look at the second bracket, it actually has got, this is 0. I'm just trying to, this is 0. This part here is going to be a 0. Arcsine of 0 is 0. And then we're going to just deal with this part. If you look at this part also, this part here, it's just going to be a 0. So in essence, we're looking for 1 over 2 times 8 times arcsine of 1, because 4 over 4 is 1. This is essentially what we're looking for. So we just punch this in our calculator. Please note your calculator should be in radians. I just have to emphasize this. Your calculator should be in radian mode. As long as you're doing calculus, you should make sure that your calculator is in radian mode. So this is 0.5 times 8. So we're simply multiplying half 8 arcsine of 1, and we make sure that we are in radian mode, as I emphasized. If we do that, we get 2 pi. So our answer here is 2 pi, because it's area, units squared. If you are required to give your answer to 3 decimal places, you just convert it to 3 decimal places. That is 6.283 units squared. This is how you solve this kind of question. I said and I repeat, you usually rely on your formula sheet to get these integrals right. Just don't forget to use your formula sheet to get the integrals right. Also, make sure you follow the original steps. These steps here, I'm just going to go back to those steps. Let's just go back to the steps that we have to follow. Let us put this off. We come to these steps here. These are the steps that you should always follow, and make sure you follow them religiously. You sketch the function and you sketch it accurately. You need a skill to sketch these graphs, so make sure you are able to sketch your graphs without any problem. Identify the required area. Once you know your required area, you have done half of the question. Then choose a differential element or a strip. It can either be a horizontal strip or a vertical strip. With practice, you're going to just know which one should you use for that particular situation. Sometimes it is more convenient to use a horizontal strip. Sometimes it's actually more convenient to use a vertical strip. Then you deduce a function in terms of one variable. Then you do the integration. I want to emphasize once again that if you are using the x here, your limit of integration should be x values. If you're using the y, your limit of integration should be y values. Very, very important. But like everything else in mathematics, it is all through practice and practice and practice. You always get it right. Thanks for watching the video. Subscribe to the channel and give a thumbs up to this video. Thank you.